says approximate the degrees of freedom. So I've done it here, but I don't recommend that you do this by hand. Use the calculator. The calculator will give you, well, you're going to put in stat, test, 2 sample t-test, and when it says pooled or unpooled, you're going to say unpooled. And it will spit out 151.4 degrees of freedom, which you will round down to 151. So I'm going to do this test at 151 degrees of freedom. T at 151 degrees of freedom, because nu from the calculator was 151.4. And this is a two-sided t-test because of this. So two-sided. So I have 2 rejection regions here, 0.025 and 0.025, for a total of alpha equals 0.05. So then I go to my t-table and I look up 0.025 with 151, but there is no 151. I go here. The maximum number is 120, and then there's z. So you could use either one. At 120 is the right way to go. So there's no 151, so use 120 degrees of freedom because of the t-table being limited. So 0.025 and 120 gives me 1.98. Z would have given me 1.96. So it's really close. Doesn't really matter which one. 1.98 and minus 1.98 are critical values. Next we find the test statistic. So T naught equals x bar minus y bar minus mu x minus mu y over radical sx squared over nx plus sy squared over ny. The reason why I'm bothering to do this by hand is because if this number were not 0, you see, when I bring this to the left side, I get mu x minus mu y equals 0 versus mu x minus mu y not equal to 0, right? If this number was something other than 0, so let's say the question said, test to see if the difference of means is 10 or something different from 10, then this number would have been 10. And that you cannot put into your calculator, which is why I'm forcing you to look at me solving this problem by hand. If this was some number other than 0, such as 10 or 20 or 5 or something else, then the calculator doesn't give you a chance to put that in, which means that they are going to be constantly using 0 here, and your test statistic will be wrong and your p-value will be wrong, which is why I'm showing you how to do this by hand. Follow me. So x bar is 207.3 minus y bar is 193.4 minus mu x minus mu y from the null. It happens to be 0 in this case, so the calculator will provide, divided by rad sx squared 35.6 square over nx plus 17.3 square over ny. So I cleaned this up and I got 3.40 as my T naught. Go and drop this 3.40 into this picture and it falls here. T naught equals 3.40. So we're going to be reject H naught, which says mu x minus mu y equals 0, in favor of HA, which says mu x minus mu y is not equal to 0. And then you're in the right rejection region, so conclude that mu x minus mu y is greater than 0 since t naught in right rejection region. So your final conclusion is this. So this is saying that children of fathers who have died of heart disease have higher mean cholesterol levels than children whose fathers are alive. Follow me? Mu x greater than mu y. How about a confidence interval for this problem? It's two-sided, so confidence interval would be appropriate, right? Let's do it. Alpha is 0.05 because none was provided. So I'll find the 95% CI for mu x minus mu y. So let's say that I don't know the formula for this, right? Which I don't. So I'm going to create it. I'm just going to create this formula. How do you create the confidence interval formula? Well, it used to be this. In the simple case, it used to be this. X bar n plus or minus T alpha over 2 S over rad n. You remember that? That's all you really have to know, and you can create the confidence interval formula as you go on along. So now it's going to be X bar minus Y bar, because I'm interested in the difference of means, plus or minus T alpha over 2 with new degrees of freedom. And then the standard deviation from the denominator of this thing. So just copy this. This is the standard deviation, X bar minus Y bar. So this thing would go next. So radical Sx squared over Nx plus Sy squared over Ny. You see how they all follow the same pattern? And now let's plug in. So X bar is 207.3 minus 193.4 for Y bar, plus or minus T alpha over 2 new degrees of freedom. We already decided that that number was 1.98, so I'll use that same number, 1.98 rad Sx squared 35.6 squared over Nx plus Sy squared over Ny. And I plugged in. So now let's get this going on the calculator. Let's work on this part first. So 35.6 squared divided by 100 plus 17.3 squared divided by 74, and take the square root of that. 4.088, so 1.98 times 4.088, and on the left side I have 207.3 minus 193.4, 13.9, and then when I multiply this I get 1.98 times 4.088, which is 8.09424. So 13.9 minus 8.09 gives me 5.81, and 13.9 plus 8.09 gives me 21.99. So we are 95% confident that the true mu x minus mu y lies in this interval. And then I draw it, 5.81, 21.99, and then I go and I drop the 0 in there. Which 0? The 0 from the null hypothesis here. H naught mu x minus mu y equals 0 versus HA mu x minus mu y equals not equal to 0. So this 0 is what I go and I drop in here. And I see that the entire confidence interval is greater than 0. So conclude that mu x minus mu y is greater than 0, or mu x greater than mu y, or mu case greater than mu control in my case. Follow me? Can this whole thing be done on the calculator? Absolutely. You just go, and I say absolutely because this is a 0 in my case. It's a 0, so the calculator will do the whole thing for you, right? So, stat, test, 2 sample, t-test. Data or stats? Stats. Oh, let me put it where you can see it. X1 bar equals 207.3, S equals 35.6, N equals 100, Y bar equals 193.4, SY equals 17.3, and N2 equals 74. And what side is this test? It's two-sided. So I picked that first option. Pooled or unpooled? Unpooled, no. And calculate. So T equals 3.399, and I got that. I got T equals 3.40, so this is confirmed. And then degrees of freedom, we cheated and we used this guy anyway. And I think we're done. Did it give us the p-value? Yeah. P-value, yeah. Here it is. So p-value, let me find my p-value first, right, and see if it matches. So this is my p-value here. Let me color the p-value in. So here's the p-value. The probability of being more than 3.40 and the equivalent area on the other side. So to find the p-value, equals 2 times t-CDF. Left endpoint is 3.40. Right endpoint is infinity. And degrees of freedom are 151. So when I do that, I'm hoping to get the same number, 8.63 times 10 to the negative 4. So let's put this where you can see it and do it. Second distribution, t-CDF, 3.40, comma 100, comma 151. And I want to double that because it's two-sided. So 8.62 times 10 to the negative 4, which is the same thing that the calculator gave me. Watch. Stat, test, 2 sample t-test. (8.63 times 10 to the negative 8.63 times 10 to the negative 4. Same answer. So the p-value is really small. It's 0.000862. And alpha is equal to 0.05. So p less than alpha reject H naught.